Hello everybody and welcome to a new series on my channel. I thought I'd step away from this flat earth stuff a little bit and talk about actually interesting and, in my mind, important stuff. And that's the Earth's atmosphere and climate and the current discussion. Because in my mind, or for me at least, when I read and watch stuff about climate change and changes in our atmosphere and our environment, I quickly realized that I don't have enough knowledge of the actual science behind it. How do those climate models actually work? How are climate changes from the Paleolithic era actually obtained? How do people research that actually? I know way too little about that, I've realized. And so I thought I'd start this channel where I discuss scientific papers that I find interesting to a reasonable depth, where I think I've understood them and hopefully you will understand them as well. And I'd also would find it interesting if we could get a little discussion going here, but we'll see how it goes. So for starters, I thought I would put things into perspective. It's always a good thing to do that when you start thinking about such a huge physically and mentally, so to speak, topic as the Earth's atmosphere. And another YouTuber who is really awesome at that is Anton Petrov. I have a screenshot of one of his videos right here. He has an awesome channel. I highly recommend it. And he talks about astrophysics and astronomy mostly on his channel. And he had an awesome video a couple days ago where he compared our closest neighboring galaxy, the M31 Andromeda galaxy, which you can actually see with your naked eye when the sky is dark enough and when you're on the right hemisphere. But when you look at it at night, and even with a basic camera setting, you only see a small, tiny fraction of it because it's so dim and the light pollution is mostly too bright in most areas. So he thought about, okay, what would Andromeda actually look like when we could look at it with the eyes of a high power telescope. And it turns out that the Andromeda galaxy is actually 6 times wider than the moon. And that's just an awesome comparison to me. It's just a great way to put things into perspective in my mind. So I thought I'd do the same thing with the Earth's atmosphere. And I took a melon, measured its radius, and then I calculated, okay, if we compare the melon to if we scale the melon radius to the Earth's radius, how thick would the breathable part of the atmosphere be around that melon? And it turns out that it's actually almost as thick as that plastic wrapping foil around that melon. So I'll show you the math in the description. But if we scale Earth's atmosphere down to that size of a melon, then Earth's atmosphere is 0.025 millimeters thick. So just as thick as this wrapping foil. So that's mindfuck number 1. Number 2, I measured the surface area of that melon-sized Earth, and then I could calculate what surface area, how big the surface area of the surrounding atmosphere is. And it turns out that is this sheet of wrapping foil of roughly 24 centimeters length and width. That's our atmosphere when we scale it to melon size. That's it. Every living thing, every being, every human, every plant, every dinosaur has breathed in that sheet of plastic foil of 0.025 millimeters thickness. So then I took it a step further and thought about CO2, because that's what everybody's talking about when we're talking about climate change. And we always hear this number 400 parts per million, 400 ppm. That's the concentration of CO2 in the atmosphere at the moment. And if we scale that to our sheet of atmosphere, our representation of the atmosphere, then this little red dot, that represents the amount of CO2 that is in the atmosphere. This is 1 millimeter right here. So you can think, okay, that's a teeny tiny amount, right? Right, it is a teeny tiny amount. But this tiny amount has effects on the atmosphere, and we see this here. So this is a graph that spans 500 million years. So this is actually 4 different time scales. So this is why there's 4 boxes. So this is 500 to 60 million years ago, and then it goes from 60 to 1 million, and then from 1 to actually 1,000 years ago, and then this time scale is the shortest. That's from 1,000 years ago to today, and even to the future. Those are climate model projections. That's the 400 part per million mark, which we've broken just a couple of years ago. And if we go back here, when the last time that CO2 was actually much higher than 400 parts per million, even 1,000 parts per million, that is roughly 230 million years ago. And a pretty interesting event happened. That's why I chose to talk about it in this video. And that's the Peruvian incident. And this has been researched quite a bit lately, and scientists have found out that actually a big extinction event happened around that time, and that extinction event actually made it possible for the dinosaurs to come into existence, because around 200 million years ago, dinosaurs started to roam the earth until around 60 million years ago. But this event, this caused a sharp increase from 400 parts per million to around 2,000 parts per million. This event was caused, it's believed today, by a huge volcanic eruption that lasted for millions of years, and it had a huge impact on the environment. As I said, most of the biome just died out. So if we put that into perspective, those 2,000 parts per million, if we compare that with our sheet of atmosphere, then those 2,000 parts per million amount to this dot. Compared to today, in relation to the whole atmosphere, this is still a tiny amount, relatively tiny. It's larger than what we have today, no doubt, but it's still a tiny amount. And this tiny amount had huge implications on our climate and caused massive disturbances and massive dying on our planet. So that's it for today. Again, short video, just trying to put things into perspective for me and hopefully for you too. If you like this video, please give me a thumbs up. I'd really appreciate it. If you have questions, remarks, critique, please leave a comment in the comment section. I'd love to start a discussion with you, and I'll see you next time. Take care.